Okay, here we have a degree 3 polynomial equation. We need to find the solutions to this equation, or the zeros to this polynomial, 7x cubed plus 97x squared plus 217x minus 33. And first of all, because this is degree 3, there are 3 solutions. The possible rational solutions are, well, it would have to be a factor of the constant term over a factor of the leading coefficient. So the possibilities are positive or negative 1, 3, 11, or 33, all over 1, or all over 7, 1 seventh, 3 sevenths, 11 sevenths, 33 sevenths. And I'll just notice that there is one sign change as you go from one term to the next. So Descartes' rule of signs tells us that there must be one positive real number solution. So 3 solutions in all, one of them is a positive number. That means the other 2 are either negative numbers or possibly non-real complex numbers. But since I know that one of them is positive, I decided to try looking for that one first. And I just picked a number off the list and stuck it out in front and did synthetic division to see if I get a remainder of 0. So here's my coefficients: 7, 97, 217, negative 33. I started by bringing down the 7. 3 times 7 is 21. 97 plus 21 is 118. 3 times 118 is 354. 217 plus 354 is 571. Things are not looking good. 3 times 571 is 1,713. Negative 33 plus 1,713 is, it's not 0, so 3 is not a 0 of this polynomial. And I do notice that all of these numbers on the bottom row are positive. So we did have a theorem that says that if you try a positive number and you get all positive numbers on the bottom row, that tells you that there cannot be any zeros or any solutions that are any bigger than what you tried. So that rules out not only 3 itself, but all of the numbers greater than 3. I'm not even going to bother trying 11 or 33 or any of those. And just looking at this, it doesn't look like 1 would work. If I put in 1 for x, I don't think things would add up to 0. So next, maybe I'll try 1/7. So I'll put that out in front of the synthetic division, bring down the 7. 1/7 times 7 is 1. 97 plus 1 is 98. 1/7 times 98 is 14. 217 plus 14 is 231. 1/7 times 231 is 33, and negative 33 plus 33 is 0. So yes, 1/7 is one of the zeros of that polynomial. So I know that, and I also know that when you divide by x minus 1/7, you get a quotient of 7x squared plus 98x plus 231. So my original polynomial can be factored into x minus 1/7 times 7x squared plus 98x plus 231. So the other 2 solutions would be the ones that make that come out to equal 0. Let's see if I can factor that. For one thing, this 7x squared plus 98x plus 231 has a common factor of 7 that I can pull out. And once I've got that 7 out of the way, the x squared plus 14x plus 33 can be factored into x plus 3 times x plus 11. So now that I have this all factored, I can see what the solutions to the equation are. X could equal 1/7, or x could equal negative 3, or x could equal negative 11. Those are my 3 solutions. 1.5 to the x power equals 100. Now be careful, this is 1.5 raised to the x power. It's not 1.5 times x. So you cannot solve this just by dividing both sides by 1.5. Division undoes multiplication, but it does not undo exponentiation. What does undo exponentiation is logarithms. I could rewrite this equation in logarithmic form as log to the base 1.5 of 100 equals x. Because that's what that means. The log to the base 1.5 of 100 means the number that you have to raise 1.5 to, the power that you have to raise 1.5 to end up with 100. Now, to actually evaluate a log to some weird base like this, we can use that change of base formula and say this is the common log of 100 divided by the common log of 1.5, and that comes out to be about 11.358. We could also use natural logs, ln of 100 divided by ln of 1.5. That would also come out to be 11.358. Five e to the 2x equals 600. First, I divide both sides by 5 to undo the 5 times part. That gives me e to the 2x equals 120. Now I undo the e with ln. The natural logarithm undoes the exponential function e. So ln of e to the 2x would just be 2x, and that's equal to ln of 120. And then to go from 2x to x, just divide both sides by 2, and x equals the ln of 120 divided by 2, and that comes out to be about 2.394. Number 17, log of x equals 7. This means the common log or base 10 log of x. So that means that 10 to the 7th power equals x. And then if you multiply that out, 10 to the 7th power would be 10 million. It would be a 1 with 7 zeros after it. Here we have an absolute value equation. Notice the absolute value bars around x minus 5. So in order for the absolute value of an expression to equal 2, that expression could equal 2 or it could equal negative 2. So that gives us two separate equations to solve, and that gives us x equals 7 or x equals 3. Here we have an inequality. 4x minus 7 is less than or equal to 13. First, I can add 7 to both sides, and I get 4x is less than or equal to 20. Then I can divide both sides by 4, and I get x is less than or equal to 5. And oops, I graphed this a little wrong. This should have been a square bracket on the graph. So do as I say, not as I do. Put a square bracket by the 5 and shade in everything to the left of that on the number line. It's a square bracket because we are including the 5. X could be equal to 5. And then as an interval, that would be the interval from negative infinity to 5. Including the 5, so I put a square bracket there. Here we have one of those three-sided inequalities where we want to end up with just plain old x in the middle. So what I did was I started by subtracting 10 from all three sides. That got me 60 is less than 1/3 x is less than 70. Then to undo the 1/3, I multiplied by 3 on all three sides, and I got 180 is less than x is less than 210. This time it is strict inequality, so we are not including the endpoints, just the numbers in between. So I do want these round parentheses. This is everything between 180 and 210. So we would write that as the interval from 180 to 210. The graph of y equals the square root of x looks like this. And then the directions say, based on this, sketch the graph of y equals the square root of x plus 4 plus 2. So the x has been replaced with x plus 4. What used to be happening to x is now happening to x plus 4, and that shifts the graph 4 spaces to the left, because now x would have to be negative 4 to get the same 0 that we originally got when x itself was 0. And the plus 2 on the end shifts everything up 2 spaces in the y direction. All the y coordinates are now what they used to be, plus 2. So the point that used to be here at 0, 0 is now over at negative 4, 2, and things go up from there. It's the same shape, it's just been shifted over 4 to the left and 2 up. Draw an example of an increasing function. Well, there's all sorts of things you can draw. Just make sure that whatever you draw goes up as you go along from left to right. So here's one possibility here. A graph that is not a function. Again, there are many different possibilities. This particular graph here is not a function because it does not pass the vertical line test. You can draw a vertical line that touches the graph at more than one point. That means that there's more than one y for the same x, so it's not a function. A function with a range of negative infinity to 4, well, here's one possibility. The y coordinates of the points that make up this graph, there's no limit to how far down they go, but they only go up to 4. So the range, when you're looking at the graph of a function, is all the y coordinates of all the points that make up the graph. So here's a graph with y coordinates that range from negative infinity up to and including 4. If we want the domain to be negative 2 to infinity, the domain on the graph is all of the x coordinates of all the points. So here I've got a graph where the points on the graph have x coordinates that start at negative 2 and then go off forever to the right. Tell what the center and radius are and then sketch the circle. X minus 9 squared plus y plus 5 squared equals 100. So this follows the general pattern, x minus h squared plus y minus k squared equals r squared. The h is 9 and the k is negative 5. Remember, it's minus whatever. So if it's minus 9, the whatever is 9. And if it's plus 5, that's like minus a negative 5. So the whatever is negative 5. So the center of this circle is at the point 9, negative 5. And then over on the other side, in the position of r squared, is the number 100. So r itself would be the square root of that, 10. So the radius of this circle is 10. And that means that if you start at the point 9, negative 5 and go 10 units in all different directions, 10 spaces right, 10 spaces left, 10 spaces up, 10 spaces down, that gives you the circle itself. Find the inverse function of f of x equals 3x minus 7. Remember, the inverse is the function that undoes what that function does. So if we interchange the x and y's so that it says x equals 3y minus 7, and then solve for y, add 7 to both sides, then divide both sides by 3, that gives us our inverse, x plus 7 over 3, or you could also write that as 1/3 x plus 7/3. So whatever you start with, if you plug it into f of x, 3x minus 7, take the result, plug that into f inverse, you should get back the number you started with. Okay, I'll stop this part of the video here and continue in the next part.